Air travel has revolutionized the way we move around the world, and a significant portion of air travel is powered by jet fuel, which is a type of fossil fuel. Jet fuel powers a wide range of aircraft, including commercial passenger planes and cargo planes. In this article, we will explore the mechanisms behind the operation of jet-powered aircraft. Jet engines are the primary means of powering aircraft that use jet fuel. The most common type of jet engine used in commercial aircraft is the turbofan engine. Turbofan engines consist of a fan at the front of the engine that draws in air, a compressor that compresses the air, a combustion chamber where the fuel is burned, and a turbine that drives the fan and compressor. When the fan draws in air, some of the air flows around the outside of the engine, while the rest flows through the compressor. The compressor then squeezes the air, increasing its pressure and temperature. The compressed air is mixed with fuel in the combustion chamber, where it is burned, creating hot gases that flow through the turbine. The turbine is connected to the fan and compressor, which are used to draw in and compress more air, creating a continuous cycle. The hot gases that flow through the turbine also produce thrust, which propels the aircraft forward. The amount of thrust produced by the engine depends on several factors, including the amount of air drawn in by the fan, the temperature and pressure of the air, and the efficiency of the engine. Another type of jet engine used in aircraft is the turbojet engine. Turbojet engines are similar to turbofan engines, but they do not have a fan at the front of the engine. Instead, all of the air drawn in by the engine flows through the compressor, where it is compressed and mixed with fuel in the combustion chamber. The hot gases produced by the combustion then flow through the turbine, which drives the compressor and produces thrust. While turbojet engines are not as common as turbofan engines in commercial aircraft, they are still used in some military and experimental aircraft. Another type of jet engine is the turboprop engine, which is used in aircraft that require less speed and altitude, such as regional passenger planes and cargo planes. Turboprop engines are similar to turbofan engines, but they use the hot gases produced by the combustion to drive a propeller instead of a fan. In addition to the mechanisms behind jet engine operation, there are several factors that affect the efficiency and sustainability of aircraft that use jet fuel. One factor is the quality of the fuel used in the engines. High-quality jet fuel that meets specific industry standards can improve the efficiency of the engine and reduce emissions. The aviation industry is constantly working to develop new, more sustainable fuels, such as biofuels made from renewable sources like algae and plant matter. Another factor is the design of the aircraft itself. Modern aircraft are designed to be more aerodynamic, reducing drag and improving fuel efficiency. They are also equipped with advanced avionics systems that help pilots navigate more efficiently and reduce fuel consumption. The way that aircraft are operated also affects their efficiency and sustainability. Pilots can optimize flight routes and speeds to reduce fuel consumption and emissions. Airlines can also use advanced scheduling software to reduce idle time on the ground and improve overall efficiency. Finally, the aviation industry is constantly working to improve air traffic management systems to reduce delays and optimize flight paths, which can further improve fuel efficiency and reduce emissions. Efficiency and sustainability are two important aspects of aircraft operation that are critical to the success and longevity of the aviation industry. Here are some additional details about these factors. Fuel quality. Jet fuel is a complex mixture of hydrocarbons that can vary in quality depending on the source and refining process. High-quality jet fuel that meets industry standards can improve the efficiency of the engine and reduce emissions. In recent years, the aviation industry has been working to develop more sustainable fuel options, such as biofuels made from renewable sources like algae and plant matter. Aircraft design. Modern aircraft are designed to be more aerodynamic, reducing drag and improving fuel efficiency. The use of lightweight materials such as carbon fiber can also reduce the weight of the aircraft, further improving fuel efficiency. Advances in engine technology have also improved the efficiency of jet engines, resulting in lower emissions and reduced fuel consumption. Operational efficiency. The way that aircraft are operated can have a significant impact on their efficiency and sustainability. Pilots can optimize flight routes and speeds to reduce fuel consumption and emissions. Airlines can also use advanced scheduling software to reduce idle time on the ground and improve overall efficiency. Additionally, air traffic management systems are constantly being improved to reduce delays and optimize flight paths, further improving fuel efficiency and reducing emissions. Sustainability initiatives. The aviation industry has made a commitment to sustainability and has launched several initiatives to reduce the environmental impact of air travel. The International Air Transport Association, IATA, has set a target to achieve carbon-neutral growth by 2020 and to reduce carbon emissions by 50% by 2050. The use of sustainable fuels and the implementation of more efficient operational practices are key components of these initiatives. The International Air Transport Association, IATA, is a global trade association of airlines that was established in 1945. It is based in Montreal, Canada, and has over 290 member airlines from around the world, representing about 82% of total air traffic. IATA aims to promote safe, secure, and sustainable air travel by setting industry standards and regulations, providing training and support to airlines, and representing the industry's interests to governments and other stakeholders. One of the key functions of IATA is to develop and implement global standards and regulations that ensure the safe and efficient operation of the aviation industry. This includes the development of standards for aircraft maintenance, training of pilots and other aviation professionals, and the implementation of safety and security measures. IATA also works with governments and other organizations to promote the harmonization of aviation regulations around the world. In addition to its regulatory and safety functions, IATA also provides a range of services to its member airlines, including training and education programs, financial and legal services, and consulting services. It also operates a number of industry-wide initiatives, such as the IATA Travel Pass, which provides passengers with a secure and convenient way to verify their COVID-19 status before traveling. Some additional information about the International Air Transport Association, IATA, includes: IATA represents airlines from over 120 countries and territories, making it one of the largest and most influential trade associations in the world. The organization has a number of subsidiary companies and partnerships, including the IATA Clearinghouse, IATA Consulting, and the International Aviation Fuel Association, IAFA. The story of the invention of the intelligent robot vacuum cleaner. The story of the invention of the smart vacuum robot is a fascinating one, full of innovation, creativity, and perseverance. The idea of a robot that could clean floors and carpets autonomously had been around for decades, but it wasn't until the early 2000s that the technology began to catch up with the vision. One of the pioneering figures in the development of the smart vacuum robot was the company iRobot, which was founded in 1990 by a group of engineers from the Massachusetts Institute of Technology, MIT. The company's first product was a military robot designed to clear minefields, but it soon began exploring the potential for consumer robotics. In 2002, iRobot released the Roomba, a small and compact robot vacuum that could navigate around homes and automatically clean floors and carpets. The Roomba was a major breakthrough in the field of robotics, using a range of sensors and algorithms to navigate and avoid obstacles, and to adjust its cleaning patterns based on the layout of the room. Over the following years, iRobot continued to refine and improve its robotic vacuum technology, releasing new models with enhanced navigation, suction power, and battery life. Other companies also began entering the market, developing their own robotic vacuum cleaners with a range of features and capabilities. Today, smart vacuum robots are a ubiquitous presence in homes and offices around the world, with millions of units sold each year. These robots are designed to make cleaning easier and more convenient, with features such as scheduling, automatic charging, and remote control via smartphone apps. The potential applications of smart vacuum robot technology are vast and far-reaching. In addition to cleaning floors and carpets, these robots can also be used for a range of other tasks, such as monitoring air quality, detecting leaks or spills, and even providing companionship and entertainment. Despite their many benefits, smart vacuum robots also face a number of challenges and limitations. These include the need for regular maintenance and cleaning, the limited range of surfaces and objects that can be cleaned, and the potential for privacy and security concerns related to the collection of data and images by the robot. As the technology continues to evolve and improve, it is likely that these challenges will be addressed through ongoing research and development. With the potential to transform the way we clean and maintain our homes and workplaces, smart vacuum robots represent a significant advance in the field of robotics, with the potential to improve and enhance our daily lives. The invention and development of smart vacuum robots have had a significant impact on the way we clean our homes and workplaces. However, the technology behind these devices is constantly evolving, and new innovations are being made to improve their functionality and performance. One area of advancement in smart vacuum robots is their ability to integrate with other smart home devices and systems. For example, some models can be controlled through voice commands using virtual assistants like Amazon Alexa and Google Assistant. Others can be programmed to work in tandem with smart lighting and security systems, allowing for greater integration and automation in the home. Another area of advancement is the use of artificial intelligence, AI, and machine learning algorithms to improve navigation and cleaning efficiency. By analyzing data from sensors and cameras, these algorithms can learn the layout of a room and adapt their cleaning patterns to achieve optimal results. In addition, advancements in battery technology and charging capabilities have allowed for longer run times and faster recharge times, making smart vacuum robots more convenient and practical for everyday use. The potential applications of smart vacuum robot technology are not limited to the home and office. In the hospitality industry, for example, smart vacuum robots are being used to clean hotel rooms and common areas, reducing the need for human cleaners and improving overall efficiency. In healthcare settings, smart vacuum robots are being used to clean and disinfect patient rooms and other high-traffic areas, reducing the risk of infection and improving patient outcomes. Despite the many advantages of smart vacuum robots, there are also some potential drawbacks and limitations. One concern is the potential for privacy and security breaches, as these devices can collect data and images from inside the home. Additionally, some models may not be suitable for certain types of flooring or surfaces, or may require regular maintenance and cleaning to ensure optimal performance. Smart vacuum robots have come a long way since their invention in the early 2000s, and their continued development shows no signs of slowing down. With the advent of new technologies and materials, the capabilities of smart vacuum robots are expanding, and their potential applications are becoming more diverse. One area of development is the use of sensors and cameras to detect and navigate around obstacles more effectively. Some models are equipped with advanced mapping capabilities, allowing them to create a detailed map of the home or office and navigate autonomously to clean the floors more efficiently. Another area of development is the use of advanced cleaning technologies, such as ultraviolet, UV, light, and electrostatic cleaning, to provide a deeper and more thorough clean. These technologies can help to eliminate bacteria, viruses, and other harmful substances from floors, carpets, and other surfaces. In addition, advancements in design and materials are making smart vacuum robots more versatile and adaptable. Some models are designed to be more lightweight and compact, while others are designed to be more rugged and durable, making them suitable for use in a wider range of environments and applications. The potential applications of smart vacuum robots are also expanding beyond traditional cleaning tasks. In the industrial sector, for example, smart vacuum robots are being used to clean and maintain large manufacturing facilities and warehouses, reducing the need for human labor and improving overall efficiency. In the agricultural sector, smart vacuum robots are being used to clean and maintain animal housing facilities, improving the health and welfare of livestock. Despite the many advantages of smart vacuum robots, there are also some potential challenges and limitations. One concern is the potential for unintended consequences, such as damage to objects or surfaces within the home or office. Additionally, some models may require regular maintenance and cleaning to ensure optimal performance, and the use of certain cleaning technologies may require additional safety precautions. Smart vacuum robots have become a ubiquitous presence in households, businesses, and industries around the world, and their continued development is driving new innovations and possibilities. One area of development is the integration of artificial intelligence, AI, and machine learning algorithms to provide more advanced and customized cleaning capabilities. By analyzing data from sensors and cameras, these algorithms can learn the layout of a room and adapt their cleaning patterns to achieve optimal results. They can also detect and identify different types of surfaces and adjust their cleaning intensity accordingly, providing a more precise and efficient clean. Another area of development is the use of advanced sensors and cameras to provide more detailed and accurate data on the cleanliness of surfaces. Some models are equipped with sensors that can detect the amount of dust and debris on a surface, allowing the robot to adjust its cleaning patterns and intensity to provide a more thorough clean. Others are equipped with cameras that can detect and identify different types of stains and spills, allowing the robot to target specific areas for more intensive cleaning. In addition, advancements in battery technology and energy efficiency are making smart vacuum robots more sustainable and environmentally friendly. Some models are designed to use less energy and require less frequent charging, reducing their carbon footprint and energy costs. Inside data storage devices. Data storage devices are an essential component of modern computing, allowing us to store and access vast amounts of information quickly and efficiently. But what goes on inside these devices, and how do they work? In this article, we'll take a closer look at the inner workings of data storage devices and explore some of the different types available. The most common type of data storage device is the hard disk drive, HDD, which uses spinning disks coated with a magnetic material to store data. The disks, or platters, are arranged in a stack and rotate at high speeds while a read/write head moves back and forth across the surface, reading and writing data to the magnetic coating. The read/write head is mounted on an actuator arm, which moves it to the correct location on the disk to read or write data. Another type of data storage device is the solid-state drive, SSD, which uses a series of interconnected flash memory chips to store data. Unlike HDDs, SSDs have no moving parts, which makes them faster, more durable, and less prone to mechanical failure. Instead of reading and writing data to a spinning disk, SSDs use electrical impulses to store and retrieve data from the flash memory chips. In addition to HDDs and SSDs, there are also a number of other data storage devices available, including USB flash drives, memory cards, and optical disks. Each of these devices uses different types of technology to store and access data, but the basic principles of data storage remain the same. One of the key considerations when choosing a data storage device is the amount of storage capacity it provides. HDDs and SSDs are available in a range of sizes, from a few gigabytes to several terabytes, while USB flash drives and memory cards typically offer more limited storage capacity. Another important consideration is the speed of the data storage device. SSDs are generally faster than HDDs, but can be more expensive, while USB flash drives and memory cards are often slower but more portable and convenient. It's also important to consider the durability and reliability of the data storage device. HDDs are susceptible to mechanical failure and can be damaged if dropped or bumped, while SSDs can be damaged by exposure to extreme temperatures or magnetic fields. USB flash drives and memory cards can also be damaged by physical impact or exposure to moisture or dust. Data storage devices have undergone significant advancements over the years, with new technologies and innovations constantly pushing the boundaries of what is possible. In this article, we'll explore some of the latest developments in data storage devices and their potential impact on the future of computing. One of the most exciting developments in data storage technology is the emergence of solid-state drives, SSDs, with 3D non-flash memory technology. This type of flash memory allows for higher storage capacity and faster read and write speeds, making SSDs an increasingly popular choice for high-performance computing applications. Another major development is the use of helium-filled hard disk drives, HDDs, which offer lower power consumption and improved data storage density compared to traditional air-filled HDDs. By filling the drive with helium, the disks can spin more easily and generate less heat, allowing for more platters to be stacked inside the drive and increasing the amount of data that can be stored. In addition, there are also new types of data storage devices emerging, such as DNA-based storage. This technology uses synthetic DNA molecules as a storage medium, allowing for vast amounts of data to be stored in a very small space. While still in the early stages of development, this technology has the potential to revolutionize data storage and create new possibilities for long-term preservation of digital information. Another area of development is the use of cloud-based storage solutions, which allow users to store and access data remotely over the Internet. These solutions offer a range of benefits, including scalability, accessibility, and cost-effectiveness. However, they also raise concerns around data privacy and security, as well as the potential for service interruptions or downtime. As data storage technology continues to evolve, it will be important to consider not only the technical capabilities of these devices but also their impact on society and the environment. The production and disposal of data storage devices can have significant environmental impacts. And it will be important to prioritize sustainability and responsible production practices in the development of new technologies. Data storage devices continue to evolve and improve, with new technologies and innovations driving advances in capacity, speed, and reliability. In this article, we'll explore some of the latest developments in data storage devices and their potential impact on the future of computing. One of the most significant developments in data storage technology is the use of shingled magnetic recording, SMR, in hard disk drives, HDDs. SMR allows for higher storage capacity by overlapping tracks on a disk, but this technology requires specialized software to manage the data and can lead to slower write speeds. However, the use of SMR is expected to increase in the coming years, as manufacturers seek to meet the growing demand for higher storage capacity. Another major development is the use of non-volatile memory express (NVMe) technology in solid-state drives, SSDs. NVMe is a high-performance interface that allows for faster data transfer between the storage device and the computer, reducing latency and improving overall system performance. By using them, SSDs can achieve even faster read and write speeds, making them an ideal choice for high-performance computing applications. In addition to these developments, there are also new types of data storage devices emerging, such as holographic storage. This technology uses lasers to create three-dimensional holographic images that can be stored and accessed on a disk. Holographic storage has the potential to offer much higher storage capacity than traditional HDDs or SSDs, but it is still in the early stages of development and has yet to be widely adopted. Another area of development is the use of artificial intelligence, AI, and machine learning algorithms to optimize data storage and retrieval. By analyzing patterns in data usage and access, these algorithms can help to improve efficiency and reduce latency, making it easier and faster to access the data you need. As data storage technology continues to evolve, there are also increasing concerns around data privacy and security. With the growing amount of sensitive information being stored on these devices, it's important to ensure that they are protected from unauthorized access or theft. This has led to the development of new security technologies, such as hardware-based encryption and biometric authentication, to help safeguard data and prevent breaches. Data storage devices are becoming increasingly important in our daily lives, as we generate and consume more information than ever before. In this article, we'll explore some of the latest trends in data storage devices and their impact on the way we store and access information. One of the most significant trends in data storage technology is the move towards cloud-based storage solutions. Cloud storage allows for data to be stored and accessed remotely over the Internet, eliminating the need for physical storage devices and providing greater flexibility and accessibility. Cloud storage also offers advantages such as scalability, cost-effectiveness, and ease of use, making it a popular choice for individuals and businesses alike. Another trend is the increasing use of flash memory in data storage devices. Flash memory is a type of non-volatile memory that can be read and written to quickly and efficiently, making it an ideal choice for storage devices such as solid-state drives, SSDs, and USB flash drives. With advancements in flash memory technology, these devices are becoming faster, more reliable, and more affordable, allowing for greater adoption and use. In addition, there are also new technologies emerging, such as DNA-based storage. This technology uses synthetic DNA molecules as a storage medium, allowing for vast amounts of data to be stored in a very small space. How X-ray machines work. X-ray machines are vital tools in modern medicine, allowing doctors to diagnose and treat a wide range of medical conditions by producing detailed images of the inside of the body. In this article, we'll take a closer look at how X-ray machines work and the different components that make up these complex devices. The basic principle behind X-ray machines is the production of electromagnetic radiation in the form of X-rays, which can penetrate through the body and create an image. X-rays are generated by an X-ray tube, which consists of a cathode and an anode. The cathode emits a beam of electrons, which are accelerated towards the anode. When the electrons collide with the anode, they produce X-rays, which are then directed towards the patient. To produce an image, the X-rays must pass through the patient's body and be detected on the other side by a digital X-ray detector. The X-ray detector is typically composed of a scintillator, which converts the X-rays into visible light, and a photodetector, which converts the light into an electrical signal that can be processed and displayed on a computer. In addition to the X-ray tube and detector, X-ray machines also include a range of other components to ensure accurate and safe operation. These may include a collimator, which helps to focus the X-ray beam and reduce unnecessary exposure to radiation, as well as a lead-lined room or shielded enclosure to protect operators and patients from radiation exposure. It is also important to consider the proper use and maintenance of X-ray machines to ensure their safe and effective operation. This may include regular calibration and testing to ensure accurate and consistent imaging, as well as proper training and certification for operators to ensure that they are using the machine correctly and safely. Tiek tuc va kong trung lap. X-ray machines are an essential part of modern medicine, allowing doctors to diagnose and treat many medical conditions by producing detailed images of the body. In this article, we'll explore in more detail how X-ray machines work, including the different types of X-rays and the importance of safety and maintenance. There are several types of X-rays used in medical imaging, including radiography, computed tomography, CT, and fluoroscopy. Radiography is the most common type of X-ray, which uses a single X-ray beam to produce a two-dimensional image of a specific area of the body. CT scans, on the other hand, use multiple X-ray beams to produce a 3D image of the body, while fluoroscopy produces real-time images of the body in motion. The basic operation of X-ray machines is similar across all types. An X-ray tube is used to generate a beam of X-rays, which is directed towards the body. The X-rays pass through the body and are detected on the other side by a digital X-ray detector. The amount of X-rays that pass through the body is absorbed by different tissues and structures to varying degrees, depending on their density and thickness. This creates an image that can be used to diagnose medical conditions and plan treatments. However, it is important to consider the potential risks associated with X-ray imaging. Exposure to ionizing radiation can increase the risk of cancer and other health issues, particularly if the patient is exposed to high levels of radiation over a long period of time. To minimize this risk, X-ray machines are designed to use the lowest possible dose of radiation necessary to produce a clear image. It is also important to ensure that X-ray machines are properly maintained and calibrated to ensure accurate and safe operation. This may include regular testing and calibration, as well as proper training and certification for operators to ensure that they are using the machine correctly and safely. X-ray machines are a crucial tool in modern medicine, enabling doctors to diagnose and treat a wide range of medical conditions by producing detailed images of the inside of the body. In this article, we'll explore in more detail the different components of X-ray machines, including how they produce X-rays, how images are captured, and the importance of safety and maintenance. The heart of an X-ray machine is the X-ray tube, which produces the X-rays that pass through the body and create an image. The X-ray tube consists of a cathode and an anode, which are separated by a vacuum. When an electric current is passed through the cathode, it causes electrons to be emitted and accelerated towards the anode. When the electrons collide with the anode, they produce X-rays that are directed towards the patient. To produce an image, the X-rays must pass through the patient's body and be detected on the other side by an X-ray detector. The detector is typically composed of a scintillator, which converts X-rays into visible light, and a photodetector, which converts the light into an electrical signal that can be processed and displayed on a computer. To ensure that the X-ray beam is properly focused and directed at the patient, X-ray machines also include a collimator, which is a device that helps to limit the size and shape of the X-ray beam. In addition, lead-lined rooms or shields are used to protect the operator and other individuals from radiation exposure. It is also important to consider the safety and maintenance of X-ray machines. Exposure to ionizing radiation can be harmful, so X-ray machines are designed to use the lowest possible dose of radiation necessary to produce a clear image. Operators of X-ray machines must be properly trained and certified to ensure that they understand the risks and can operate the machines safely. In addition, X-ray machines must be properly maintained and calibrated to ensure that they are operating correctly and producing accurate images. Regular testing and calibration are necessary to ensure that the X-ray machine is functioning properly and producing the lowest possible dose of radiation. X-ray machines are an integral part of modern medicine, allowing for the diagnosis and treatment of a wide range of medical conditions. In this article, we'll dive deeper into the different types of X-ray machines and their applications, as well as the advancements in technology that have improved their functionality and safety. There are several types of X-ray machines, each with their own unique applications and benefits. Radiography is the most common type, which uses a single X-ray beam to produce a two-dimensional image of a specific area of the body. Computed tomography, CT, scanners, on the other hand, use multiple X-ray beams to produce a 3D image of the body, providing a more detailed analysis of the area being examined. Fluoroscopy is another type of X-ray machine that produces real-time images of the body in motion, making it useful for procedures such as surgery or catheterizations. Advancements in technology have also led to improvements in X-ray machines, both in terms of functionality and safety. Digital X-ray detectors have replaced traditional film-based detectors, providing higher resolution images with lower radiation doses. Additionally, The use of software algorithms has improved image processing and analysis, allowing for more accurate diagnoses and treatment planning. Another significant advancement in X-ray technology is the development of cone beam computed tomography, CBCT, which uses a cone-shaped X-ray beam to produce a 3D image of the body with higher resolution and less radiation exposure. This technology has revolutionized dental and orthopedic imaging, providing more detailed information for diagnosis and treatment planning. Discover the process of making sugar crushers. Sugarcane is a widely grown crop in many parts of the world, and the process of refining sugar from sugarcane involves several important steps, including crushing the cane to extract its juice. In this article, we'll explore the process of manufacturing sugar cane crushers, including their components and operation. Sugar cane crushers are machines that are used to crush sugar cane in order to extract its juice. The juice is then processed further to produce refined sugar. Sugar cane crushers are typically large machines that are powered by electric motors or diesel engines. The basic components of a sugar cane crusher include a feeding chute, a set of rollers or blades, and a frame to hold the machine in place. The sugar cane is fed into the machine through the feeding chute, where it is crushed by the rollers or blades. The juice is then collected in a container or trough, while the remaining pulp is expelled through a separate outlet. The crushing process of sugar cane involves a series of steps, including shredding, crushing, and milling. The sugar cane is first shredded by a series of rotating blades, which breaks it down into smaller pieces. These pieces are then fed into the crusher, where they are further broken down into a pulp. The pulp is then passed through a series of mills, which extract the juice and separate it from the remaining pulp. One of the key factors in the operation of a sugarcane crusher is the speed of the rollers or blades. The speed of the machine must be carefully controlled in order to ensure that the sugarcane is properly crushed and that the juice is extracted efficiently. Too high of a speed can result in the sugar cane being crushed too finely, while too low of a speed can result in the juice not being extracted properly. Sugarcane is a widely grown crop in many parts of the world, and the process of refining sugar from sugarcane involves several important steps, including crushing the cane to extract its juice. In this article, we'll explore the process of manufacturing sugar cane crushers, including their components and operation. Sugar cane crushers are machines that are used to crush sugar cane in order to extract its juice. The juice is then processed further to produce refined sugar. Sugar cane crushers are typically large machines that are powered by electric motors or diesel engines. The basic components of a sugar cane crusher include a feeding chute, a set of rollers or blades, and a frame to hold the machine in place. The sugar cane is fed into the machine through the feeding chute, where it is crushed by the rollers or blades. The juice is then collected in a container or trough, while the remaining pulp is expelled through a separate outlet. The crushing process of sugar cane involves a series of steps, including shredding, crushing, and milling. The sugar cane is first shredded by a series of rotating blades, which breaks it down into smaller pieces. These pieces are then fed into the crusher, where they are further broken down into a pulp. The pulp is then passed through a series of mills, which extract the juice and separate it from the remaining pulp. One of the key factors in the operation of a sugarcane crusher is the speed of the rollers or blades. The speed of the machine must be carefully controlled in order to ensure that the sugarcane is properly crushed and that the juice is extracted efficiently. Too high of a speed can result in the sugar cane being crushed too finely, while too low of a speed can result in the juice not being extracted properly. The process of refining sugar cane is an important industry in many parts of the world, providing a vital ingredient for a wide range of food and beverage products. Sugarcane crushers play a crucial role in this process, and advancements in technology continue to improve their efficiency and sustainability. One area of focus for advancements in sugarcane crushers is energy efficiency. Traditional sugarcane crushers rely on large motors to power the blades or rollers, consuming significant amounts of energy. However, newer machines use hydraulic or pneumatic systems to exert pressure on the sugarcane, reducing the need for large motors and increasing energy efficiency. Another area of focus is reducing waste and improving sustainability. In traditional sugarcane crushers, a significant amount of juice can be lost in the pulp or expelled through a separate outlet. However, newer machines are equipped with sensors and automated systems to monitor and control the crushing process, ensuring that the maximum amount of juice is extracted while minimizing waste. In addition to improvements in technology, there is also a growing emphasis on sustainable sourcing and production in the sugar industry. This includes the use of sustainable farming practices, such as crop rotation and reduced pesticide use, as well as the adoption of eco-friendly production methods, such as using renewable energy sources and reducing water usage. The importance of sustainability in the sugar industry is also reflected in the growing demand for organic and fair trade sugar. Organic sugar is produced without the use of synthetic pesticides or fertilizers, while fair trade sugar ensures that farmers are paid a fair price for their product and that labor conditions are safe and equitable. Sugarcane crushers have a long history of usage in the sugar refining industry, and their importance continues to be felt today. In addition to their use in the production of refined sugar, sugarcane crushers are also used in the production of other products, such as molasses and ethanol. Molasses is a byproduct of the sugar refining process, produced when sugarcane juice is boiled down and the sugar crystallizes out. Molasses is a rich and flavorful syrup that is commonly used in baking and cooking. It is also used as an ingredient in the production of rum and other alcoholic beverages. Ethanol is another product that can be produced from sugarcane. Ethanol is a biofuel that can be produced from a variety of sources, including sugarcane juice and molasses. In addition to its use as a fuel, ethanol is also used in the production of hand sanitizer, as well as in the pharmaceutical and cosmetic industries. The use of sugarcane crushers in the production of molasses and ethanol highlights the importance of these machines in the broader context of sustainable agriculture and renewable energy. Sugarcane is a renewable resource that can be grown and harvested year after year. By using sugarcane to produce molasses and ethanol, we can reduce our reliance on fossil fuels and promote a more sustainable and environmentally friendly energy system. Another important consideration in the sugar refining industry is the impact of sugar consumption on public health. The high levels of added sugar in many processed foods and beverages have been linked to a range of health problems, including obesity, type 2 diabetes, and heart disease. This has led to calls for reduced sugar consumption and increased awareness of the health risks associated with excessive sugar intake. In response to these concerns, some sugarcane producers and refiners are exploring alternative sweeteners. Jet aircraft operation mechanism. Jet engines are a type of gas turbine engine that are used to power airplanes and other aircraft. Jet engines operate by accelerating a large amount of air through a narrow nozzle, producing a high-velocity jet of exhaust gases that propels the aircraft forward. In this article, we'll explore the mechanics of jet engines and how they operate. There are several different types of jet engines, but all of them operate on the same basic principle: the compression and combustion of air and fuel to produce a high-velocity exhaust stream. The most common type of jet engine is the turbojet, which consists of a compressor, a combustion chamber, a turbine, and a nozzle. The compressor takes in air from the atmosphere and compresses it, increasing its pressure and temperature. The compressed air is then mixed with fuel in the combustion chamber, where it is ignited and burned. The resulting high temperature, high-pressure gases expand rapidly, driving the turbine and generating power to drive the compressor and other engine components. The exhaust gases are then directed through the nozzle, which is designed to accelerate the gases and produce a high-velocity jet of exhaust. This jet of exhaust produces the thrust that propels the aircraft forward. In addition to the turbojet, there are several other types of jet engines, including the turbofan, which uses a large fan to increase the amount of air that is accelerated through the nozzle, and the turboprop, which uses a turbine to drive a propeller rather than a nozzle. One of the key advantages of jet engines is their high power-to-weight ratio. Jet engines are able to produce a large amount of thrust relative to their size and weight, making them ideal for powering airplanes and other aircraft. Another advantage of jet engines is their ability to operate at high altitudes and speeds. Jet engines are able to maintain a high level of performance at high altitudes, where the air is thin and the engines of other types of aircraft may struggle to produce lift. Jet engines are a marvel of engineering, and their operation is a complex and intricate process. To ensure that they operate safely and efficiently, jet engines are subject to rigorous testing and maintenance procedures. One key aspect of jet engine maintenance is regular inspections. Jet engines are designed to operate at high temperatures and pressures, which can cause wear and tear on the engine components over time. Regular inspections can help identify any potential issues before they become serious problems, and ensure that the engine is operating within safe parameters. Another important aspect of jet engine maintenance is cleaning. The high-velocity exhaust produced by jet engines can leave behind deposits of carbon and other materials on the engine components, which can reduce the engine's efficiency and increase the risk of damage. Regular cleaning can help remove these deposits and ensure that the engine is operating at peak performance. In addition to inspections and cleaning, jet engines are also subject to regular maintenance and repair procedures. This can include replacing worn or damaged components, such as turbine blades or bearings, as well as performing more extensive repairs, such as engine overhauls. One of the challenges of jet engine maintenance is the high level of precision required. Jet engines operate at extremely high speeds and temperatures, and even minor variations in the engine components can have a significant impact on performance and safety. As a result, jet engine maintenance requires a high level of skill and expertise, as well as specialized tools and equipment. Advancements in technology have also led to improvements in jet engine design and maintenance. For example, some newer engines are equipped with sensors and monitoring systems that can provide real-time data on engine performance and identify potential issues before they become serious problems. In addition, advances in material science and engineering have led to the development of lighter and more durable engine components, which can improve efficiency and reduce maintenance requirements. Another important aspect of jet engine maintenance is testing. Jet engines are tested extensively before they are put into service, and they undergo regular testing throughout their operational life to ensure that they are operating within safe parameters. Testing can involve a range of procedures, including engine run-ups, vibration analysis, and structural inspections. One of the key challenges in jet engine testing is ensuring that the tests are as accurate and representative as possible. Jet engines operate in a complex and dynamic environment, and replicating these conditions in a testing environment can be difficult. To address this challenge, jet engine manufacturers and operators use a range of tools and techniques, such as computer simulations and wind tunnel testing, to model and test engine performance under a variety of conditions. In addition to maintenance and testing, another key aspect of jet engine operation is fuel efficiency. Jet engines are one of the most fuel-efficient types of engines, but they still consume a significant amount of fuel. To improve fuel efficiency, jet engine manufacturers and operators are constantly exploring new technologies and techniques, such as advanced materials and coatings, more efficient combustion processes, and alternative fuels. Reducing the environmental impact of jet engines is also a key concern for the aviation industry. Jet engines produce greenhouse gas emissions, such as carbon dioxide and nitrogen oxides, which contribute to climate change and air pollution. To address these concerns, the aviation industry is exploring a range of strategies to reduce emissions, such as improving fuel efficiency, using alternative fuels, and implementing emissions reduction technologies, such as exhaust gas recirculation and lean burn combustion. One of the ongoing challenges in the development of jet engines is balancing competing demands such as power, efficiency, and noise reduction. Jet engines are designed to produce a high amount of thrust, but this also means they can be loud, which can have negative impacts on local communities near airports. To address this issue, manufacturers are developing new technologies such as noise-reducing engine components and advanced acoustic modeling to help reduce the noise impact of jet engines without sacrificing performance. Another area of focus in jet engine technology is safety. While jet engines are generally considered safe and reliable, there is always the potential for mechanical failure or human error. To address this, manufacturers are developing new safety technologies, such as predictive maintenance systems and advanced sensors that can detect potential issues before they become serious problems. In addition to safety, cybersecurity is also becoming an increasingly important consideration in jet engine design and operation. Modern jet engines contain a range of electronic components and systems that are vulnerable to cyber attacks, which can have serious safety and security implications. To address this, manufacturers and operators are implementing cybersecurity measures such as firewalls, data encryption, and intrusion detection systems. Finally, the future of jet engines is likely to be shaped by advances in automation and artificial intelligence. The helicopter invention process. The development of the helicopter, or rotary wing aircraft, was a significant milestone in the history of aviation. Unlike fixed-wing aircraft, which require a runway for takeoff and landing, helicopters are capable of vertical takeoff and landing, making them well-suited for a range of applications, from military operations to search and rescue missions. The idea of a rotary wing aircraft dates back centuries, but it wasn't until the early 20th century that practical helicopter designs began to emerge. One of the earliest pioneers in this field was Igor Sikorsky, a Russian-American engineer who is credited with designing and building the world's first successful helicopter, the Versus 300, in 1939. The Versus 300 was a single-engine, single-rotor aircraft that used a series of mechanical linkages to control the pitch and yaw of the rotor blades. The aircraft made its first successful flight in September 1939, and over the years, Sikorsky and his team continued to refine and improve the design, leading to the development of the first practical helicopter, the Sikorsky R-4, in 1942. The R-4 was a significant breakthrough in helicopter technology, and it played a critical role in World War II. Performing a range of missions such as medical evacuation, reconnaissance, and supply transport. After the war, the R-4 and other early helicopter designs became the basis for a new era of aviation. And helicopters quickly found applications in a range of industries, from transportation to agriculture to law enforcement. Over the years, helicopter technology has continued to evolve and improve, with advances in materials science, electronics, and other fields leading to the development of more advanced and capable aircraft. Today, helicopters are used for a wide range of applications, from military and law enforcement operations to offshore oil and gas exploration to emergency medical services. While the history of the helicopter is one of ongoing innovation and discovery, it is also a reminder of the importance of persistence and determination. The early pioneers in this field faced numerous challenges and setbacks, but they persevered, driven by a vision of a new era of aviation that would revolutionize transportation and change the world. The development of the helicopter was a complex and challenging process, requiring a deep understanding of aerodynamics, materials science, and mechanical engineering. One of the key challenges in designing a successful helicopter was achieving the right balance of power, weight, and stability. One of the earliest approaches to helicopter design was the autogyro, a type of aircraft that uses a rotor to generate lift but relies on an engine-driven propeller for forward motion. While autogyros were capable of vertical takeoff and landing, they were limited in their speed and range, and they were quickly surpassed by more advanced helicopter designs. One of the breakthroughs in helicopter technology was the invention of the swashblade, a complex mechanical system that allowed for precise control of the rotor blades. This innovation was critical in enabling helicopters to achieve greater stability and maneuverability, and it paved the way for the development of more advanced helicopter designs. Another important innovation in helicopter technology was the use of composite materials, such as carbon fiber, to reduce the weight of the aircraft while maintaining strength and durability. This enabled the development of more efficient and capable helicopters, capable of carrying heavier payloads and flying longer distances. In addition to advances in technology, the development of the helicopter was also shaped by the needs of various industries and applications. Military and law enforcement agencies, for example, required helicopters that could perform a range of missions, from reconnaissance and surveillance to troop transport and combat support. Meanwhile, the commercial aviation industry was focused on developing helicopters that could transport passengers and cargo more efficiently and safely. Today, helicopters continue to evolve and improve, with ongoing innovations in materials science, electronics, and other fields leading to the development of more advanced and capable aircraft. From the early autogyros of the 1920s to the sophisticated helicopters of today. The evolution of the helicopter is a testament to the power of human ingenuity and the ongoing quest for innovation and discovery. The development of the helicopter also faced significant challenges in terms of safety and reliability. Helicopters are complex machines with many moving parts, and accidents and mechanical failures were common in the early years of development. One of the key challenges in improving helicopter safety was developing systems and technologies to improve stability and control. This led to the development of advanced control systems, such as fly-by-wire technology, which uses electronic signals to control the movement of the aircraft rather than mechanical linkages. Another important safety innovation in helicopter technology was the development of advanced avionics, such as GPS navigation and terrain awareness systems, which enable pilots to navigate and operate more safely in a range of conditions. In addition, safety features such as crash-resistant fuel systems and advanced rotor blades have helped to reduce the risk of injury and damage in the event of an accident. Despite these safety innovations, helicopters remain one of the most challenging and demanding types of aircraft to operate, requiring highly skilled and experienced pilots and maintenance personnel. To address this, the aviation industry has invested heavily in training and education programs, as well as in the development of simulation and training technologies to help pilots and maintenance personnel develop the skills and expertise needed to operate and maintain helicopters safely and effectively. Looking to the future, the helicopter industry is facing a range of new challenges and opportunities, from the development of autonomous and electric helicopters to the increasing demand for urban air mobility and other emerging applications. By embracing innovation and collaboration, and by continuing to prioritize safety and reliability, the helicopter industry can play a critical role in shaping the future of aviation and enabling new forms of transportation and economic growth. The development of the helicopter has also had a significant impact on a range of industries and applications, from military and law enforcement to transportation and tourism. Helicopters are highly versatile aircraft that are capable of performing a wide range of missions, and they have become a critical tool for many organizations and businesses around the world. One of the key applications of helicopters is in military and law enforcement operations, where they are used for reconnaissance, surveillance, and combat support. Helicopters are also used for search and rescue missions, where their ability to hover and land in remote or difficult-to-reach locations can be critical in saving lives. In the commercial aviation industry, helicopters are used for a range of applications, from transporting passengers and cargo to supporting offshore oil and gas exploration and production. Helicopters are also used in the tourism industry, where they provide a unique and exciting way for people to see and explore the world around them. In addition to these traditional applications, the helicopter industry is also exploring new and emerging applications, such as urban air mobility and package delivery. With advances in autonomous and electric helicopter technology, it is becoming increasingly feasible to use helicopters for a wide range of applications in urban environments, from transportation to emergency response to public safety. Despite these opportunities, the helicopter industry also faces a range of challenges, from safety and reliability to environmental sustainability and noise pollution. To address these challenges, the industry is exploring a range of strategies and technologies, from advanced control systems and avionics to alternative fuels and electric propulsion. Looking to the future, The helicopter industry will continue to play a critical role in shaping the future of aviation and enabling new forms of transportation and economic growth. By embracing innovation and collaboration, and by prioritizing safety, reliability, and environmental sustainability, the helicopter industry can help to create a more connected, prosperous, and sustainable world for all. Another important aspect of the development of the helicopter is the impact it has had on scientific research and exploration.